Here's a great example of a chain rule question that they could easily ask on a Calculus 1 midterm or final exam. It kind of takes your knowledge of derivative rules and sort of stretches it to the extreme because we have multiple rules being at play at once. So when we're asked to find dy by dx, that's just to go through and find the derivative in terms of x. When we have multiple functions at once, what we want to think about is the chain rule. And the chain rule says you basically take the derivative of your outermost function, rewrite what's inside that function, and then multiply by the derivative of what's inside afterwards. So I'm going to quickly rewrite this because it's sine squared of ln of 3 root x. You can see there's lots of multiple brackets there. Sine squared of something is the same as sine of that thing. So sine of ln of 3 root x, close that bracket, all squared. So we write the 2 in here normally, but this is what it means. So now I'm going to go ahead and find dy by dx. And you'll want to stick with me here. So we're going to start from the outside and work our way in. So the outermost function we see is something to the power of 2. Okay, great. When we know we have something to the power of 2, chain rule says we bring that 2 down, rewrite exactly what's inside. So you can just sort of do a blind copy here. I'm just writing what's inside there. And it's now to the power of 1. But the chain rule says you do that on the outside and then you look inside the bracket and take the derivative of that. So what's the derivative of what's inside the bracket? Well, that's a sine function. Derivative of a sine function says we take the cos of that function. So again, I'm just rewriting what's inside the sine function, but cos, because cos is the derivative of sine. But now that we also say times the derivative of what's inside the angle. So we see we have still a function of x here. So we're going to multiply by the derivative of that. Well, the derivative of a ln function is 1 over whatever's inside the ln, which happens to be 3 root x. Almost done, because the derivative of ln is 1 over what's inside times the derivative of what's inside. So we're now taking the derivative of the piece inside the ln. And the derivative of 3 root x is 3 over 2 root x. And that is your full dy by dx. Again, start from the outside. So the furthest outside thing we saw here was an exponent rule. We bring that exponent to the front, rewrite the term to the new exponent, and then multiply by the derivative of what's inside. If you keep saying that to yourself, multiply by the derivative of what's inside, by the derivative of what's inside, you can go and there can be 40 functions within one, and as long as you stay on that path, you'll have a bunch of terms that look pretty messy, but at least you'll stay on track. Hopefully this is helpful. You can always email us, info@arnoldtutoring.com, with more calculus questions. Thanks.